Next week goes our next chapter. The chapter is mensuration. Okay, then in this chapter we discussing about the perimeter and area. We already learned some ideas about the perimeters and areas of triangle, parallelograms, squares, rectangle and circle. Okay, here we are discussing some more ideas based on the areas and perimeter. Okay, then first we are discussing the areas of a trapezium. Then we know what do you mean by trapezium. Yes, it's very clear, trapezium is a quadrilateral, correct. Then when we say a quadrilateral is a trapezium, a pair of opposite sides are parallel. In the case of a quadrilateral, a pair of opposite sides are parallel, then we call it as a trapezium, correct. So how do we find out a area of a trapezium, that we are discussing now. Okay, then we know in the case of trapezium a pair of opposite sides are parallel. Okay, so just we draw a trapezium. In this trapezium we mark the two side measurements A and B. Then it's very clear the side A and B are parallel. Okay, and the non-parallel sides are these two. Okay, then it's very clear what is that. In the case of a trapezium, a pair of parallel sides are A and B, and the distance between that parallel side we denoting by h. Okay, so if we know the measurements of two parallel sides and the distance between that parallel sides, then it's possible to find out the area of a trapezium. So we using the equation, yes, area is equal to half into h into a plus b. Okay, what is a and b? A and b are the parallel sides and h is a distance between them. Then the area is equal to half into h into a plus b. Okay, that means in the case of a trapezium it is possible to find out the area when if we know the measurements of two parallel sides and the distance between that parallel side. Okay, we are denoting the parallel sides. In the case of trapezium we are denoting the parallel sides are a and b, and the distance between the parallel sides is h. So area is equal to half into h into a plus b. Okay, the first example is the shape of the top surface of a table is a trapezium. Find its area if its parallel sides are 1 meter and 1.2 meter and the perpendicular distance between them is 0.8 meter. Okay, here is very clear that tabletop, okay, is in the shape of a trapezium. The is given the shape of the top surface of a table is a trapezium, means the top of the table in the shape of a trapezium, and is given the two parallel sides and the distance between the parallel sides, the perpendicular distance between the parallel sides. Okay, and what is the question? Find the area. The question asks find its area. Here is clearly given what is the shape of top of a table, the tabletop in the shape of a trapezium. So for find out the area of tabletop we want to use the equation of trapezium, correct. So how do we find the area of a tabletop? Yes, area of a tabletop is equal to, we know what is the shape of tabletop. Yes, the tabletop in the shape of trapezium. So area of a tabletop is equal to half into h into a plus b, correct. Half into h into a plus b. Then what is denoting a and b? The a and b denoting the parallel sides. And what is h? H is denoting the distance between the parallel sides, correct. So what are given? Here is clearly given the parallel sides are 1 meter and 1.2 meter and the perpendicular distance between them is 0.8 meter. Correct. So next we choosing the value of a and b. We choose the value of a is equal to 1 meter, b is equal to 1.2 meter and h is equal to 0.8 meter. Okay, the next we substitute the value in this equation. Therefore area is equal to half into what is h? H is 0.8 into a plus b means 1 plus 1.2. Okay, then is possible to reduce 2 and 0.8 is 0.4. Okay, then is equal to 0.1 into 0.4 is 0.4 into 1 plus 1.2 is s 2.2. Correct. Next we want to multiply 0.4 and 2.2. Then how it will be multiply? We know that we just avoid the decimal point, we neglect the decimal point, correct? Then we multiply 4 and 22, correct? 4 and 22, what is 4 and 22? Yes, 88. Then if we multiply 4 and 22, we get the answer is 88. Then in this answer we need to put the decimal point after 2 digit, correct? Here is the decimal point is here, the decimal point after 1 digit, here the decimal point after 1 digit, then total 2 digit. So in this answer we put the decimal point after 2 digits, so 1 2, then answer is yes, 0.88 square meter. Okay, 0.88 square meter. So what is the area of the tabletop? Yes, in this case the area of the tabletop is equal to 0.88 square meter. 0.88 square meter. It's a direct application of yes, area of a trapezium. Okay. The next example is the area of a trapezium shaped field is 480 square meter. The distance between the two parallel sides is 15 meter and one of the parallel side is 20 meter. Find the other parallel side. Okay, then is very clear what are given. Here is given the area and is given one parallel side and is given the distance between the two parallel side, and the question asks to find the other parallel side. Okay, so this is another application of area of a trapezium. Okay, then first we started like this, we are writing here what are given. Okay, so what are given? Area is equal to 480 square meter and is given the distance between the two parallel sides is 15 meters. So we are denoting the distance between the two parallel sides by the letter h. So h is equal to 15 meter. And given one of the parallel side is 20 meters, we use the letters to denote the parallel sides are a and b. So we choose here the value of a is equal to 20 meter. We don't know the value of b, so we choose the value of b is equal to x meter. Okay, so how do we apply? So we use the equation of area of a trapezium because the area is already given. Then how do we find the area of trapezium? Area is equal to half into h into a plus b. Okay, is an equation based on the area of a trapezium. So in this equation we are substituting the values what are given. Okay, then area is given, what is area? 480. Therefore 480 is equal to half into what is h? H is 15 into a plus b. A plus b means 20 plus x. 15 is not possible to divide exactly by 2, so it's not necessary to divide like that. We keeping like this 1 by 2 into 15 into 20 plus x. So it's not possible to divide exactly. The next steps we just transpose 2 in the side of LHS. Okay, we transpose 2 in the side of LHS, then what do you get? We get the result is a by 2, then is transposed as into 480 into 2 is equal to 15 into 20 plus x. Okay, then 480 into 2, then we get the answer, what do you get? 960 is equal to 15 into 20 plus x. Okay, then after we have the two idea, first expand the bracket, then after transpose 1 by 1, or otherwise here we multiplying 20 plus x commonly by 15, so we first transpose 15 in the side of LHS. Okay, നമുക്ക് ഇവിടുന്ന് രണ്ട് രീതി ചെയ്യാം മക്കളെ. ഒന്ന്, ഇവിടുന്ന് ബ്രാക്കറ്റ് എക്സ്പാൻഡ് ചെയ്യുക, 15 into 20 plus 15 into x എന്ന് എഴുതിയിട്ട് എക്സ്പാൻഡ് ചെയ്തിട്ട് നമ്പേഴ്സ് ഇപ്പുറത്തേക്ക് കൊണ്ടുവരാം. അല്ലെങ്കിൽ നമ്മളിവിടെ കോമൺ ആയിട്ട് 20 പ്ലസ് എക്സിനെ ഏതുകൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുന്നുണ്ട്? 15 കൊണ്ട് കോമൺ ആയിട്ടാണ് മൾട്ടിപ്ലൈ ചെയ്യുന്നത്. അതുകൊണ്ട് ഈ കോമൺ ആയിട്ട് മൾട്ടിപ്ലൈ ചെയ്യുന്ന 15 നമുക്ക് ഇപ്പുറത്തേക്ക് കൊണ്ടുവരാം. The both are correct. So here we transposing 15 first. Okay, then it's an into 15, then the case what is the changes is divided by 15, then 960 divided by 15 is equal to what are remaining? 20 plus x. Okay, then 960 divided by 15. The next dividing 960 by 15. Okay, 960 by 15. 60 by 15. Then how many times 15 goes to 96? Yes, 15 goes to 96 6 times. Then yes, 90. Correct? Then 60. Then how many times 15 goes to 60? 15 goes 60 in 4 times. Remainder is 0. So 960 divided by 15 is equal to 64. Therefore 64 is equal to 20 plus x. Therefore x is equal to, we transpose 20, then we know what you get, 20, 64 minus 20. 64 minus 20 is equal to, yes, 44 meter. Correct? 44 meter. Then what is 44? Then we know the other parallel side is equal to 44 meter. That is other parallel side is equal to 44 meter. Okay, so what is 44? 44 is the value of other parallel side. So we got it. What is the value of other parallel side of this trapezium? Yes, the other parallel sides of this trapezium is equal to 44 meter. Okay, I think you got the idea about the applications of a trapezium, area of a trapezium. Here we are discussing the next one. That one is a rhombus. We know what is rhombus. What is rhombus? Rhombus is a parallelogram with all sides are equal. Okay, here we are discussing how to find the area of a rhombus. We already know how to find the area of a parallelogram. How to? Yes, the equation to find the area of a parallelogram is equal to b into h. Correct? Then what is b? B is base or one side of the parallelogram, and h is the height or the distance from that side to opposite. Okay, here we are discussing the other one. What is that? Yes, a rhombus. Okay, then what is rhombus? Don't forget the idea. Rhombus is also a parallelogram with all sides are equal. Here we are discussing how to find the area of a rhombus. Okay, then the equation is, in the case of a rhombus, if d1 and d2 are the diagonals of a rhombus, then area is equal to half into d1 into d2. Okay, that means for find outing the area of a rhombus, what are we needed? We needed the diagonal measurements. Okay, then how do we apply the area? How do we apply the idea of area in the case of a rhombus? For find outing the area of a rhombus, we needed the things. What are the diagonals of a rhombus? What are the diagonals? We denoting the diagonals are d1 and d2. Okay, for example, in this figure is the figure ABCD is a rhombus. So we mark the two diagonals. First one is AC and the second one is DB. AC is denoting D1 and DB is denoting D2. The measurement of AC is D1 and the measurement of DB is D2. So therefore the area of this rhombus ABCD is equal to half into D1 into D2. Okay, don't forget the idea. For find outing the area of a rhombus, we needed only the two things. What are they? Two diagonal measurements. Okay, so the equation is half into d1 into d2. D1 and d2 are denoting the diagonals of the rhombus. Clear? The first application of area of a rhombus is like this. The diagonals of a rhombus are 7.5 centimeter and 12 centimeter. Find its area. So direct question, what are given? Here is given Yes, the diagonal measurements of the rhombus. Then the question asks to find area of the rhombus. Okay, so we start in directly. Okay, then what is the area? The equation of area of a rhombus is equal to, yes, half into d1 into d2. Then we know what is d1 and d2. d1 and d2 are denoting the diagonal measurement. Okay, so here is also given the two diagonal measurements. The one is 7.5 centimeter, another one is 12 centimeter. So we just marking the values of d1 is equal to 7.5 centimeter and d2 is equal to 12 centimeter. Okay, so we are substituting the values in this equation. Therefore area is equal to half into 7.5 into 12, correct? Then it's very clear, is possible to reduce 2 and 12 is 6 times, then 7.5 into 6, correct? Then we know how to multiply 7.5 and 6. We multiply 75 and 6, correct? Then what is 75 into 6? 75 into 6 is equal to 30. Then 3 balance. Then 42. 42 plus 3 is 45. Correct? Then in this answer we need to put the decimal point after one digit, because here we have the decimal point only after one digit. So this answer is 45.0. So 45.0 is same as 45 square centimeter. Correct? So what is the area of this rhombus? Area of this rhombus is equal to 45 square centimeter. Here we go to the next question. The question is, the area of a rhombus is 240 square centimeter and one of the diagonal is 16 centimeter. Find the other diagonal. Okay, then what are given? Here is given the area of a rhombus and one of the diagonals, and the question asks to find the other diagonal. Okay, then this type of question we done in the case of a trapezium also. The same idea we use here is an application of the area of a rhombus. Okay, so how do we start? First we starting what are given, we are writing what are given. Here is given area is equal to 240 square centimeter and is given one of the diagonal. Okay, so we are denoting the diagonals in the form of d1 and d2. So the first diagonal we choosing here, yes, d1. Okay, the d1 is given. What is d1? d1 is equal to 16 centimeter. d1 is equal to 16 centimeter. We don't know the value of d2, so we choose the d2 is equal to x. Okay, so how do we start? Therefore area is equal to, what the equation of area of a rhombus? Yes, half into d1 into d2. Therefore we know the value of area. What is area? 240. Then 240 is equal to half into, what is d1? d1 is 16 into d2 is x, correct? Then we just checking, is possible to reduce 2 and 16? Yes, is possible, correct. If not possible, what is next? We transpose 2 in the side of LHS. Okay, നമുക്ക് 2നെ 16 കൊണ്ട് ഇവിടെ റെഡ്യൂസ് ചെയ്യാം. ഇനി റെഡ്യൂസ് ചെയ്യാൻ പറ്റാത്ത നമ്പറാണ് ഇവിടെ ഉള്ളതെങ്കിൽ നമ്മൾ എന്താ ചെയ്യുക? നേരത്തെ ചെയ്തതുപോലെ 2നെ ഇപ്പുറത്തേക്ക് ട്രാൻസ്പോസ് ചെയ്യും. അപ്പോൾ 2നെ ട്രാൻസ്പോസ് ചെയ്യുമ്പോൾ എന്താ കിട്ടുക? 240 into 2 എന്നാവും. Okay, clear? So here is possible, so we no need to worry about that. Then 16, how many times? 8 times. Therefore 240 is equal to 8 into x, correct? So for find outing the value of x, next we transpose 8 in the side of LHS. Therefore 240, yes, by 8 is equal to x. Then how many times? H goes to 24, 3 times, then 30 times, correct? Therefore x is equal to 30. Then what is x? X is the second diagonal, correct? So what will be the next? Therefore we concluding length of second diagonal is equal to 30 centimeter. Okay, so what is the length of the second diagonal in this case? The length of the second diagonal in this case is 30 centimeter. Okay, we go to our next question. The question is like this: find the area of a rhombus whose side is 6 centimeter and whose altitude is 4 centimeter if one of its diagonal is 8 centimeter, 8 centimeter long, find the length of the other diagonal. Okay, here we have the two questions. The first question is direct, find the area of a rhombus. And the second question, here is given the one diagonal measurement. Then after, the question asks to find the second diagonal measurement. Okay, so according to the question, we just constructing a figure. Okay, is a rhombus, and what are given? Here is given, yes, one side measurement. Rhombus whose side is 6 centimeter. We know is a rhombus and all side measurements are 6 centimeter, and whose altitude is 4 centimeter. Correct. Altitude means the height. That height from 6 to other side is equal to, yes, the perpendicular, the distance, the height is equal to, yes, 4 centimeter, and is given one more, is that, what is that? One of its diagonal is 8 centimeter. One of its diagonal is 8 centimeter. Okay, then what is our first question? The first question is very clear. We need to find the area of a rhombus. Okay, what is the equation we studied to find the area of a rhombus? Yes, we studied the equation to find the area of a rhombus is equal to half into d1 into d2. Correct. Yes, what is d1? d1 is one diagonal measurement and d2 is the second diagonal measurement. We studied like this. If we know the two diagonal measurement, then only is possible to find the area of a rhombus. But here we need to find the area of rhombus, but it's not given the one diagonal measurement. Here is given only one diagonal measurement. In this type of situation, how do we find the area of a rhombus? We just think what are given here. Here is given the side measurement, one side of the rhombus and the distance from that side to the opposite. Correct? നമുക്ക് ഇവിടെ എന്താണ് പകരം തന്നിരിക്കുന്നത്? ഒരു ഡയഗണൽ തന്നിട്ടില്ല, പകരം തന്നിരിക്കുന്നത് എന്താണ്? ഇവിടെ നമുക്ക് ഒരു സൈഡും ആ സൈഡിൽ നിന്ന് അതിൻ്റെ ഓപ്പോസിറ്റിലേക്കുള്ള ഡിസ്റ്റൻസും തന്നിട്ടുണ്ട്. ഒരു സൈഡല്ല, എല്ലാ സൈഡും. വി ഗിവൺ ദ വൺ സൈഡ് മീൻസ് ഓൾ സൈഡ്സ് ആർ 6 centimeter and is given one distance from one side to other. ഓക്കെ, ഒരു സൈഡിൽ നിന്ന് അതിൻ്റെ മറ്റേ സൈഡിൽ അതിൻ്റെ ഓപ്പോസിറ്റ് സൈഡിലേക്കുള്ള ഡിസ്റ്റൻസ്, പെർപെൻഡിക്കുലർ ഡിസ്റ്റൻസ് എത്രയാണെന്ന് പറഞ്ഞിട്ടുണ്ട്? 4 centimeter ആണെന്ന് പറഞ്ഞിട്ടുണ്ട്. So that means here is given one side measure, the side measurements and the distance from one side to opposite. Okay, then based on this, how do we find the area? That time we recalling the idea, yes, rhombus is also a parallelogram. Okay, so rhombus is also a parallelogram means there is possible to apply the equation of area of a parallelogram for find out the area of rhombus. നമുക്ക് മനസ്സിലായി, നമുക്കറിയാം എന്താണ് റോംബസ് എന്ന് പറയുന്നത് ഒരു പാരലോഗ്രാം ആണ്. അപ്പോൾ റോംബസ് ഒരു പാരലോഗ്രാം ആണെങ്കിൽ നമുക്ക് റോംബസിൻ്റെ ഏരിയ കണ്ടുപിടിക്കാൻ ഏതിൻ്റെ ഇക്വേഷൻ അല്ലെങ്കിൽ ഏതിൻ്റെ ഐഡിയ അപ്ലൈ ചെയ്യാം? പാരലോഗ്രാമിൻ്റെ ഐഡിയ അപ്ലൈ ചെയ്യാം. ഓക്കെ, then what is the equation for finding the area of a parallelogram? Yes, b into h. B means one side measurements, and what is h? H is the distance from that side to opposite. Then that is given here, the one side measurement we know, and the distance from that side to opposite also we know. What is that? Side is 6 and the distance is 4. Then here is possible to find out the area of a rhombus by using area of a parallelogram. Why? Because rhombus is a parallelogram. Okay, then it's a different one. Here we find out in the area of a rhombus by using area of a parallelogram. Okay, so we start in like this. Rhombus is also a parallelogram. Therefore, area of a rhombus is equal to, yes, we apply the equation of area of parallelogram. Okay, that is b into h is equal to, what is b? B is the one side measurement. What is the one side measurement? 6 into, what is h? H is the distance from that side to opposite. That one is 4. Then 6 into 4 is equal to 24 square centimeter. So we will get here what is the area of a rhombus. The area of a rhombus is equal to 24 square centimeter. Okay, then you just suppose that if we know the second diagonal measurement, okay, if we know the second diagonal measurement and we use the equation half into d1 into d2 for find out in the area of this this rhombus, what we get the answer. Okay, if suppose if we know the second diagonal measurement and we use the equation half into d1 into d2 for find out in the area of this rhombus, what we get the answer? Yes, we get the same answer. Yes, 24 square centimeter. അല്ലേ, നമുക്ക് D1 അറിയാം, D2 കൂടി അറിയാമെന്ന് വിചാരിക്കുക. D2 കൂടി രണ്ടാമത്തെ ഡയഗണൽ കൂടി നമുക്കറിയാം എങ്കിൽ നമ്മൾ ഈ ഈ റോംബസിൻ്റെ ഏരിയ കണ്ടുപിടിക്കാൻ ഏതാണ് യൂസ് ചെയ്യുക? സാധാരണ അപ്ലൈ ചെയ്യുന്ന ഇക്വേഷൻ ഏതാണ്? ഹാഫ് ഇൻറ്റു D1 ഇൻറ്റു D2 എന്ന് അപ്ലൈ ചെയ്യും അല്ലേ. അത് വെച്ചിട്ട് കണ്ടുപിടിച്ചാലും നമുക്ക് ഇതിൻ്റെ ഏരിയ എത്രയാണ് കിട്ടുക? ഈ റോംബസിൻ്റെ ഏരിയ എത്ര തന്നെ ആയിരിക്കും? ഏരിയ മാറില്ല, ഒരു ഷേപ്പിൻ്റെ ഏരിയ എപ്പോഴും എന്ത് തന്നെ ആയിരിക്കും? സെയിം ആയിരിക്കും. അപ്പോൾ D1 ഇൻറ്റു D2 ഹാഫ് ഇൻറ്റു D1 ഇൻറ്റു D2 എന്ന് പറയുന്ന ഇക്വേഷൻ വെച്ച് കണ്ടുപിടിച്ചാലും ഈ റോംബസിൻ്റെ ഏരിയ എത്ര തന്നെ ആയിരിക്കും? 24 സ്ക്വയർ സെൻറ്റിമീറ്റർ തന്നെ ആയിരിക്കും. ഓക്കെ, ദാറ്റ് ഈസ് ആൻ ഐഡിയ വി യൂസിങ് ഹിയർ. ഓൾസോ ഏരിയ ഓഫ് എ റോംബസ് equal to half into D1 into D2. We don't know the value of D2. Here we find out in the value of D2. Okay, then if we use this equation also, what we get? The area of a rhombus. Area of a rhombus is remain same. What is that? Is 24. Correct. Therefore 24 is equal to half into what is a D1? The one diagonal measurement is given, that one is 8. Half into 8 into D2. Here is possible to reduce 2 and 8, that is 4 times. Therefore 24 is equal to 4 into D2. Therefore D2 is equal to 24 by 4 is equal to 6. Correct. Then what we get? We get here, yes, therefore the second diagonal is equal to 6 centimeter. Okay, idea we using here little changes. Here we apply how to find the area of a rhombus. Here we find out in the area of a rhombus by using the area of a parallelogram. Okay, all other ideas are same. If we use any method, we get same area of one figure. ഓക്കെ, നമ്മൾ ഏത് മെത്തേഡ് യൂസ് ചെയ്താലും ഒരു ഫിഗറിൻ്റെ ഏരിയക്ക് എന്തുണ്ടാവില്ല? വ്യത്യാസം ഉണ്ടാവില്ല. അതാണ് നമ്മളിവിടെ അപ്ലൈ ചെയ്യുന്നത്. ഓക്കെ, ഐ തിങ്ക് യു ഗോട്ട് ഇറ്റ്.